In this video, we're going to show you how to do a hypothesis test for a sample mean drawn from data drawn from a normal distribution with a known variance or standard deviation. So, some years ago, the police completed a large survey of the speeds of motorists along a sea highway, timing vehicles between two car parks. They concluded that the mean speed was 29 miles per hour, with a standard deviation of 2.5 miles per hour. After complaints from the residents, the police decided to investigate if there had been an increase in motorist speeds. They then worked out the average speed of 15 randomly selected motorists. The speeds in miles per hour were as follows, and these are given in that table. 15 samples, 15 in the sample size. State the assumption you need to make about the speeds for the test to be valid. State a suitable and alternate hypothesis, and use the sample data to carry out the hypothesis test at 5% significance level. State the conclusion. So, we have the assumption is that the original data is normally distributed. Okay, in order to do the test, first of all we have to state the null and alternate hypothesis. So 80 will be that mu is 29. There's been no change in the speed. The speed was 29 miles per hour. H1 is that mu is greater than 29. There has been an increase in the average speed. So, state the type of test we're going to use. Now, because we're looking for a definite increase, then we have to do a one-tailed test. And we will be looking in the upper tail to see if there's been an increase. So then we have to state the distribution. Now, the x bar, the sample mean, is normally distributed with a population mean mu and a variance of sigma squared over n, or a standard deviation of sigma divided by the square root of n. So x bar is normally distributed with a mean of 29 and a standard deviation of 2.5, variance of 2.5 squared over 15. So next we need to calculate the test statistic. So we need to calculate the sample mean from the sample. So the sample mean is the sum of x divided by n, which is going to be 455 if you add these all up, divided by 15, which gives a sample mean of 30.3 recurring miles per hour. Right, next we need to calculate the critical value. So if we have, red means the standard normal variable, this means the normal distribution where mu is 29. So the standard deviation will be sigma over root n, which is 2.5 over root 15. And for the standard normal variable, that would be 1. Right, we need to calculate the value of z that goes with 30.3 recurring, and we need to find the value where we have in the upper tail 0.05 and in the lower tail we have 0.95. Now we can get that value from our calculator, so if we go to the calculator and then go, if we use, you can do this on a Casio as well, but using the TI, if we go to menu and then 5 probability and then 5 distributions, and we go to inverse normal, so we want from minus infinity up to that point, so we want to go 0.95, leave this as 0 and 1, because we're considering the standard normal curve, we want the value of z that goes, and we get the value of z being 1.645. You can also do that with the Casio calculator as well. So we put that value there, 1.645. Now when we calculate our value, if it lands on that side of that line, then we will reject H0. If it lands on this side of the line, then we will not reject H0. So calculating the critical value. So we wanted probability that x bar is greater than 30.3. To get to z from x bar, we need to do x bar minus the mean divided by, it's always divided by the standard deviation, but the standard deviation in this case is sigma divided by the square root of n. So that will be, z will be 30.3 recurring minus 29 divided by 2.5 over the square root of 15. And make sure you put 30.33333 or the fraction in your calculator. That gives you the probability that z must be greater than 2.065. Now, where is that on this scale here? Well, 2.065 is somewhere over here. So at this point, you put a mark. So I've got a blue mark there, roughly where it is. So that is to the right of the critical value. So we can now make a conclusion. So the conclusion will be, as 2.065 is bigger than the critical value 1.645, we will reject, because it's landing in that area, and say there is significant evidence that there has been an increase in speed. Right, that's one way of doing it. Now, an alternative way is to use what's known as p-values. So this is an alternative method for the conclusion. So in doing this, you need to calculate probability of x bar being greater than 30.3 recurring for x bar being normally distributed with 29 with a variance of 2.5 squared over 15. So you can do this on the calculator as well. So you go to menu, probability, distributions, normal CDF. You change the lower bound to 30 point, put as many threes as you can in. The upper bound is a very high number, so 9e, you can put 1,000 if you want, to the 999. The mean for that was 29, and the standard deviation is going to be 2.5 divided by the square root of 15, and then press OK, and you'll get this value, which is 0.0194 to three significant figures. So what we're saying there, so 0.1943. Now, as 0.1943 is less than 0.05, this was the critical value for a 5% test, you reject 80 and get the same conclusion as before. So this is doing that with p-values. This is called p-values. It's an alternative method than using this. Now, if you've got one of those more expensive calculators, then it's possible to carry out the whole test without you just using the calculator. So I'll just show you how to do that. So it's either like you've got one of the, not a Class Whiz, but a TI Nespar or a more expensive Casio calculator. I'm going to be using the TI Nespar. So what you need to do is open up a spreadsheet. So to do that, you do on and then both spreadsheet. I've already put the data in. So you put change the title to speed or something. List all the data. So we've got all the data here down to 15 values. Make sure you enter them correctly. Then put the cursor on the first one there, and now do menu, go to statistics, and then go to stat tests. Okay, and you're going to do a Z test. The input method is the data that we put in. We press OK. It was drawn from a mean of 29 and a standard deviation of 2.5, so that's of the original data. We want it to consider, if you've labelled the list, it's easy just to change that to speeds. Each one of those occurs one time only, frequency. We were doing a one-tail test, sorry. We were looking for the alternative hypothesis to be bigger than the mean, and we put the data in the first results column, and we press OK, and we get, lo and behold, we get all the information that we have. We've got that critical value that we just calculated, which is 2.065. or using the p-value. We've got the sample mean as well from that data, and then it's what it was actually drawn from. Okay, and then you've got the number and the sample size as well. Okay, so this has been a video. This is the unbiased estimate of the standard deviation. That's why we don't get exactly 2.5. Okay, so this has been a video to show you how to do a hypothesis test. Okay, although you can do it on your calculator, it's a good idea to know how to write out all the steps and get right in the correct information at the right place. Okay, I hope you've understood, and I'm sorry this video is quite long. Thank you very much for watching.